This video is about how to find the inverse function. As we know, not all the functions have an inverse function. Only one-to-one function has an inverse function. Inverse function is denoted as this one. Original function and inverse function are reflected across y equals x. Any function and its inverse function satisfy these two equations. We will use the escape button to remember the steps for finding inverse function. E stands for exchange xy. S stands for solve for y. C stands for change y into inverse function symbol. Now let's do some practice. Find the inverse function for given functions. Show the domain and the range of inverse function. As we know, the domain and the range switch for original function and the inverse function. So sometimes you have to figure out the domain or range of original function to figure out the domain and the range of inverse function. Use the escape button to remember the steps of finding inverse function. Therefore, the first step, exchange xy. Fx, that means y. So we got x equals negative 3y squared plus 5. Then second step, remember that it's a solve for y. You count the y is a variable. We could say this is a power pattern equation. So we isolate the variable on one side. We subtract the 5 both sides. X minus 5 equals negative 3y squared. Then we divide by negative 3. You got the y squared equals, remember negative sign cannot be denominator, so we change the sign for every term in this fraction. We got negative x plus 5 over 3. Then we got to do square root of both sides. Don't forget this plus or minus here. Since this y basically is the domain for the original function, because we switch xy, and for this y they said greater than or equal to 0. That's the reason we only choose positive here. Then we got negative x plus 5 over 3. Then last step, you change y into inverse symbol equals square root negative x plus 5 over 3. We need to figure out the domain and the range of an inverse function. We are already given the domain of our original function. Therefore, we'll get the range. That is y greater than or equal to 0. We got from here. That's the range. Domain of our original function is the range of our inverse function. So how you get the domain for this inverse function? Inverse function is a square root of function. Domain part is a radicand greater than or equal to 0. Therefore, we solve this inequality. We multiply by 3 both sides. Since we multiply by positive, symbol stay. You got negative x plus 5 greater than or equal to 0. Then we subtract 5 both sides and divide by negative 1. Remember that when you multiply, divide by negative number, you have to switch the symbol. So we use mommy, daddy, nanny to remember this rule. Since we divide by a negative number, we got to switch the symbol. X less than equal to 5. Therefore, domain will be x less than equal to 5 for this inverse function. Now let's go to D. Fx equals 2x minus 6 over 1 minus x. Exchange x, y. So we got the x equals 2y minus 6, 1 minus y. Second step is solve for y. Since this is a fraction, we get rid of the fraction by doing cross multiply. X times 1, that's x. X times negative y, that's minus xy, equals 1 times 2y, that's 2y. 1 times negative 6 is minus 6. Since we solve for y, this is a linear pattern equation. Move all y on one side. So move over here. X go to the other side. Remember, cross the equal sign, you need to change the sign. So we got the negative xy minus 2y equals negative x minus 6. When you go to this far, this is a very popular equation for SAT. For SAT question like this, solve for A. 3a minus 5 equals 4ab plus c. This is a linear pattern equation, so we'll move all a on one side. Then we got 3a minus 4ab equals 5 plus c. Next step, we take a out. We do common factor. So we get 3 minus 4b equals 5 plus c. The next step, divided by 3 minus 4b both sides. Then we got a equals 5 plus c, 3 minus 4b. Remember, this is a very critical common factor, this a. Now let's go back to the inverse function part. For you get negative xy minus 2y, we know you factor y for this part. You get the negative x minus 2 equals negative x minus 6. Then you divide it by negative x minus 2 both sides. We got the y equals. For fraction, the first term of the denominator normally is positive, so we switch sign for everything. Then we got x plus 6 over x plus 2. Then last step, change y into inverse function symbol. We got x plus 6, x plus 2. Now we need to figure out domain and the range of the inverse function. For this inverse function, this is a rational function, so we can figure out domain. That's the denominator not equal to 0, so we got the x not equal to negative 2. That's the domain for inverse function. But how you get the range? For a rational function, there's no clue for the range. So we go back to the original function. What's the domain for original function? We set up 1 minus x not equal to 0. Then we got the x not equal to 1. the domain of original function will be the range of inverse function. That's why we change y not equal to 1. Just switch this x into y, we got the range of inverse function. Now let's go to E. F of x equals square root of 4x plus 1 minus 5. Still, we got to use the step, that's escape button. F of x, that's y. So first step is a switch xy. We got the x equals square root 4y plus 1 minus 5. Then we solve for y. We know this is a square root of equation, isolating. So we add 5 both sides. We got the x plus 5 equals square root of 4y plus 1. Then we do square both sides. You will get the x plus 5 squared equals 4y plus 1. Then we solve for this y. This is a linear pattern, isolating this y on one side. So we do x plus 5 squared minus 1 equals 4y. Then you need to divide it by 4 both sides. You will get the y equals x plus 5 squared minus 1 over 4. The last step, change y into inverse symbol equals x plus 5 squared minus 1 over 4. Then we need to figure out the domain and the range of inverse function. For square root of function, inverse function is a quadratic function. For quadratic function, it's hard to figure out the domain range. So go back to square root of function. For square root of function, how to figure out the domain? We set up radicand is greater than equal to 0. So 4x plus 1 greater than equal to 0. We solve for that is x greater than equal to negative 1 over 4. Then we got the range, that is y greater than equal to negative 1 over 4. Then how to get the range for this square root of function? Remember, whenever you have square root, that means y greater than equal to 0. Nothing to multiply. Therefore, just minus 5. We got the y greater than equal to negative 5. That's the range of original function. In other words, it will be the domain of inverse function. That is x greater than equal to negative 5. So when you have a square root of function, it's easy for us to figure out domain and a range. Then switch domain and a range to get domain and a range of inverse function. Now let's go to J. This is an exponential function. We want to figure out the inverse function. Still, we got to use the escape button. Switch xy. So x equals 3e negative 4y minus 1. Second step, solve for y. You solve for exponential equation now. Isolate that exponential equation on one side. Therefore, I add 1 both sides equals 3 times e negative 4y. Then you got to divide it by 3 both sides. And you will get the e negative 4y equals x plus 1 over 3. Then we do natural log both sides. For natural log of e, we cancel. Then we got the negative 4y equals natural log x plus 1 over 3. Then we divide it by negative 4. We got the y equals negative 1 over 4 natural log of x plus 1 over 3. Then last step, you change y into inverse function. That is negative 1 over 4 natural log of x plus 1 over 3. We need to figure out the domain and the range of inverse function. For this inverse function, we can figure out the domain because this is a logarithm function. Argument x plus 1 over 3 has to be greater than 0. We solve this inequality, multiply by 3 both sides. You got the x plus 1 greater than 0. So subtract 1 both sides, we got x greater than negative 1. That's the domain for this inverse function. Range, it will be all real numbers.